Hello, today we will talk about the REF protection relay, restricted earth fault protection relay. We will learn the basic principle of the REF relay. So here is the LV winding of the transformer, or could be HV winding of the transformer. Basically, it's used with the star connected winding, and REF protection relay used to protect the internal zone of the star winding. So from the neutral to the winding, internal winding of the transformer. So here the three cities are attached with the line. So it's called line city, and they measure the current for protection purpose. And there's one more city here which called neutral city. Now in normal condition, when the load current is flowing from the winding towards the outside point, so it's flowing like this. When the current is balanced, the total vector sum of the neutral current is IA plus IB plus IC. So the vector sum of the balanced three-phase current will be 0. So when the load is balanced, the overall current of the balanced current of the all three city will be 0 amps. So there will be no current flowing through the city, and that way there will be no current will be flowing through the neutral, because it's the balanced current. So the current will be balanced in the all three phase, and there will be no current in the neutral. So there will be no current detected by the neutral city or the line city, and relay will not operate. Now this relay is used to protect the inner zone of the transformer winding. So assume there is a fault outside of the protection zone. So this is the um, from here to here, this is the inner zone, and here outside of the relay, it's outside of the city is the outer zone. So it will not protect the outside zone. Now we will see how it's work. So assume there is a fault on a red phase, and it's shorted with the earth somewhere, and so that the earth current will flow from red phase at earth point, shorting point, to the earth through the ground towards the source of the fault current. So it will flow from here through the neutral city into the winding, through the red winding. It will go pass through the city, R phase city. So the current here at the R phase will be 1000 amp normal current plus fault current 500 amps. It will be total 1500 amps will flow through the first primary winding. So the secondary winding, the CT ratio here is 1000 by 1 amps. So here it will flow 1.5 amp from the secondary of the R phase CT, and the rest of windings are balanced like 1000 amps. So the CT line CT2 and line CT3 will have a balanced load, I mean 1 amp. Now what happened is, because there is a 500 amps extra flowing through the R phase, so now the winding is unbalanced. So the net secondary current from the CT will be 0.5 ampere, because this 500 ampere add an extra 0.5 ampere in the circuit. So the net current will flow 0.5 ampere here through the line CT, because the primary current is flowing here. So the CT will sense 1500 amps. So and this CTs will sense only 1000 amps. So 1 amp, 1 amp, and 1.5 amp. So resultant current will be 0.5 amp will be flowing towards from the all three cities are connected parallelly. So the 0.5 amp resultant current will flow from the secondary city. secondaries of cities, line cities. Now same time here at the earth fault, 500 amp fault current will flow here. It will go through the neutral city towards the R phase. So it will go through the neutral city towards the winding. So the secondary current will flow in opposite direction of the primary current. So in the city normally the secondary current flows in the opposite direction of the primary current. So it will flow here like this in this direction. So this city is also 1000 by 1 amp, 1 amp city. So because 500 amp flowing through the neutral city, 0.5 amp will flow into this direction here through this winding and through here. So now 0.5 ampere here, 0.5 ampere here. So the phase angle of this city is similar, but the value is equal and opposite direction. So it will cancel each other. And the so 0.5 ampere coming from the city, line cities, and because of the unbalanced load in the R phase city, and the 5 ampere sensing occur here at the neutral city, that will be a result of 0.5 ampere flowing through the neutral city secondary. So that will be in opposite direction of the line city. So both similar current in opposite direction will cancel the resultant current will be zero, will cancel each other, and relay will not operate. Now assume the fault will occur. Now assume the fault occur here after the winding, but inside the protection zone before the city. So that is the internal zone. From here to here, this is internal zone. So now if the fault occur here, then the fault current will flow from red phase winding through the earth fault towards the ground and towards the ground through the neutral city towards the source back to the R phase. So now what happened here is the resultant current here will be 1000 amp because the fault occur here. So the load current here could be 1500 here, but the 500 amps will go towards the ground and resultant current here will be 1000 amps. So 1000 amp, 1000 amp and 1000 amp in all three phases. So because the all three phases are balanced here and CT will sense the 1000 amps, so the resultant current of the secondary winding of the all line cities will be 0 amp. So will be 0 amp here. So will be no current flowing through the secondary winding here. But here where the fault occur at the winding, now the current will assume the 500 amps, the same fault current, same fault occur here of 500 amp fault current is flowing from the secondary winding through the ground, through this neutral city and going towards the neutral point of the transformer LV winding and through the R phase winding. So because the direction of the line primary current of the neutral city is towards the winding, the secondary will flow in the opposite direction like this, will flow this way here, and now there's 0 amp here. Now it's now flowing 0 amp here, no ampere because of the balance load here, balance load. There's no amp flowing this way, and so hence only 500 amps of the full current is creating the 0.5 amp of secondary neutral city current here will come here, and because this is the balance load and it's create the high impedance, so the current will not go through the high impedance because of the balance load here in the city. The current will flow through the relay and it will operate the REF relay, which will give a trip command trip command to circuit breaker and it will open the circuit breaker, which is probably at the primary side, could be at the primary side, could be at the secondary side, or at the both side. So we can protect the transformer by using the REF relay. But this REF relay will only protect the internal john of the transformer. It will not help with the external john of the transformer. So this is the concept of the REF protection relay.